Today, we're diving deep into the world of operating systems, one of the most fascinating and complex areas in computer science. Specifically, we're talking about deadlocks, a nightmare scenario that can bring your entire system to a screeching halt, causing major headaches for users and administrators alike. Imagine this: you've got multiple processes running on your computer, all vying for the same resources, like a group of people all trying to grab the same item at once. These resources could be anything from printers to files to network connections, or even memory and CPU cycles. Now, a deadlock occurs when these processes get stuck in a standoff, each holding onto a resource that another process needs, refusing to budge. It's like a traffic jam where every car is blocking the intersection. This creates a bottleneck where nothing can move forward, and the entire system grinds to a halt. It's like a multi-car pileup on the digital highway, bringing everything to a standstill, and no one can move an inch. And trust me, nobody wants that. It's incredibly frustrating and can lead to significant downtime. Deadlocks are a serious issue in operating systems because they can lead to system crashes, data loss, and a whole lot of frustration. They can disrupt business operations and lead to financial losses. That's why understanding what causes them and how to avoid them is crucial for any aspiring tech enthusiast. By learning about deadlocks, you can better design systems that are robust and efficient, ensuring smoother operations. So, what exactly causes these digital traffic jams? Why do our systems sometimes come to a grinding halt, leaving us frustrated and helpless? Well, there are four main culprits, often referred to as the four necessary conditions for a deadlock to occur. Let's break them down in detail to understand how they contribute to this digital standstill. 1. Some resources, like a printer, can only be used by one process at a time. This is known as mutual exclusion. This exclusivity, while necessary to ensure proper functioning, can pave the way for deadlocks if not managed properly. If multiple processes need the same resource and it's not available, they end up waiting indefinitely. 2. Imagine a process holding onto a resource, like a file, while waiting for another resource, like a printer, that another process is holding onto. This is known as hold and wait. This creates a dependency chain that can quickly spiral into a deadlock. Each process is waiting for a resource held by another, creating a vicious cycle of waiting. 3. Imagine a process refusing to release a resource it's holding, even if another process desperately needs it. This is called no preemption. This lack of preemption, or the ability to forcibly take back a resource, fuels the deadlock fire. Without the ability to reallocate resources, processes remain stuck. 4. The mother of all deadlock conditions is circular wait. This happens when multiple processes are stuck in a circular chain of waiting, each holding a resource that the next process in line needs. It's a never-ending loop of dependency. It's like a game of hot potato, but nobody wants to drop the potato, even though it's about to explode. Each process is waiting for the next to release a resource, but no one does. All four of these conditions must be present for a deadlock to occur. They work together to create a perfect storm of inactivity. Remove even one, and you've successfully averted disaster. By breaking any link in this chain, you can prevent the system from grinding to a halt. Now that we understand the enemy, let's talk about how to defeat it. In the digital world, deadlocks can be a significant hurdle, but with the right strategies, we can navigate through them effectively. Deadlock avoidance is all about being proactive, implementing strategies to prevent these digital pileups from ever happening in the first place. It's about foreseeing potential issues and addressing them before they become problematic. Think of it like this: instead of waiting for a car crash to happen and then cleaning up the mess, wouldn't it be better to have traffic rules and safety measures in place to prevent the crash altogether? Just as traffic lights and signs guide drivers, deadlock avoidance strategies guide system processes. That's what deadlock avoidance is all about. It's a preemptive approach to ensure smooth and efficient system operations. There are several approaches to this, each with its own strengths and weaknesses. Some common strategies include resource allocation graphs, safe states, and the banker's algorithm. This visual tool helps us analyze resource allocation and identify potential deadlock situations before they occur. By mapping out resources and processes, we can foresee conflicts and address them proactively. By carefully controlling how resources are allocated, we can ensure that the system always stays in a safe state, where deadlocks are impossible. This involves meticulous planning and constant monitoring. This classic algorithm, which we'll explore in more detail later, uses a resource allocation model to determine whether granting a resource request could potentially lead to a deadlock. It's like a financial institution ensuring it has enough reserves before approving a loan. The goal is to strike a balance between maximizing resource utilization and preventing those dreaded deadlocks. Efficient resource management is key to maintaining system stability and performance. It's a delicate dance, but with the right moves we can keep our systems running smoothly. By implementing these strategies, we can ensure that our digital environments remain efficient, reliable, and free from the disruptions caused by deadlocks.